Today I'm going to explain you the concept of binomial expansion. So in the concept of binomial expansion, you need to know the following things. So let's start with it. Our topic is binomial expansion. Before I start with it, you need to know the actual meaning of binomial. It is made up of two words. Bi means two and nomial mean terms. How to expand the two terms when we have some power, the integer power on it. Suppose if I have here a plus b raised to the power 5. So when we expand it, how many terms we will get and what type of expansion will come in front of us. If we use our previous concept, which we took it in IGCSE, it means the same bracket is multiplying 5 times. And if you do this thing, you will definitely take too much time to expand all of these 5 brackets. To save your time, we must have a formula which tells us that how the expansion looks like and how many terms it will have. Right? So let's start with a plus b raised to the power 0. A plus b raised to power 0, anything power 0, it is always equals to 1, which is very simple. A plus b raised to the power 1, any number which has a power 1, you get the same number, a plus b. So you need to keep an eye on this. If you have 1, you get how many terms? 2 terms. Let's try another one. A plus b raised to the power 2. So a plus b raised to the power 2 means the same bracket is multiplied how many times? 2 times. Let's do it. A times a is a squared. A times b is ab. B times a is ba, but I will write it as ab. And b times b is b squared. Now, can we combine AB and AB? It will give us 2AB plus B squared. Again, I will ask you, look at the power 2. How many terms we get? 1, 2, 3. 3 terms we got it. So can you make a guess if I will write A plus B whole power 3? No, we can't. But maybe you can make a conjecture that if I have the power 3, I will get 4 terms. This is just like my guess on the basis of what I have seen before, the expansions. Let's try. Can I write a plus b whole power 3 as a plus b and a plus b whole power 2? And this one has already expanded. Can I copy the expanded form? Here I just copy a plus b, and this expansion is already done here. So a squared plus 2ab plus b squared. Now let's try to expand. A times a squared will give you a power 3, then 2 a squared, because a times a is a squared b plus ab squared. Now, a squared b, can I write it vertically down where I have a squared b? So a squared b, and then I multiply b with 2ab, it gives me 2ab squared. So the like terms are written vertically aligned, or they are seen here vertically written. It will help us to add the two like terms easily. And then b times b squared will give you b power 3. So the time has come to add the like terms. So this is 2a squared b plus 1a squared b. It will give you how much? 3a squared b plus 1 plus 2 is 3ab squared plus b power 3. I think one guess is true, that if the power is 3, we will get 4 terms. But is it possible to guess the powers? I think also we can guess the power. Look at that. If the power is 3, the first number, I start with the maximum power, and then each time the power is decreased by 1. From 3 to 0, the power is decreased and with a step of 1. And the second number in the bracket in this binomial expansion, which was b, the power was decreased from 0 till 3 with a step of 1. So its power is increased each time by 1. Another interesting thing, we can see the sum of the powers. 3 plus 0 is 3. 2 plus 1, which is also 3. 1 plus 2, the sum of the powers of a and b, it is also 3. And 0 plus 3, the sum of the powers is also 3. Wow. This is another characteristic which we have seen in every in the expansion and in every term. So sum of the powers in every term is the same as the actual power for which we need to do the expansion. Up till now, we are not clear how this 1 comes, 3 comes, this 3, and this 1. So these 1, 3, 3, 1 are called binomial coefficients. They are called binomial coefficients. I can make one more guess. What is that? Look, if you have the first number 1, your last number is 1. If your second number is 3, your second last number is 3. Maybe I will see this case in bigger power, during the expansions. Like here, the power was 3. Let's try with a plus b whole power 4. Let's do this expansion. I will write a plus b and multiply it with a plus b whole power 3. A plus b will be written as it is, and a plus b whole power 3, which was already found in the previous expansion. Let me copy it. A cubed plus 3a squared b plus 3ab squared plus b power 3. Now I want to do the expansion, guys. Apply the distributive property. Let's see what I'm gonna get. A power 4 plus 3a power 3b plus 3a squared b squared plus a b power 3. Then a cube b, then a squared b squared, then 3ab cubed, then b power 4. So guys, here it was 3. Clear? Let's try to add them up together. This is a power 4. This will be how much? After the addition of like terms, I'm getting 4a cubed b. Add them together. I get 6a squared b squared. And then I add them together, which gives you 4a b cubed plus b power 4. As you know, this was the expansion of a plus b whole power 4. First thing, power 4. How many terms? 1, 2, 3, 4, 5. Our guess was correct that we are going to get 5 terms. Since our power is 4, so in the expansion, we will get one more term, so 5 terms. So our guess was accurate. Number 2, let's look at the sum of the power. So this is 4, and if I want to write here b, so the b power 0 must be written over here. So guys, 4 plus 0, which is 4. This is 1. So 3 plus 1, the sum of the powers, it's again 4. 2 plus 2, the sum of the power is 4. 1 plus 3, sum is 4. A power 0, 0 plus 4. The second guess is also true. The sum of the powers are is equal to the actual power, before the expansion, or for which we have done the expansion. So sum is also accurate. So second guess is correct. The third guess, which we have made it, that the coefficients, the binomial coefficients, are occurring in the in this series in a symmetrical order. What is the symmetrical order? If the first coefficient is 1, the last coefficient is also 1. Wow, it is. If the second coefficient is 4, the last coefficient is 4. and the middle one is 6. So the third guess is also true, that the binomial coefficients, they occurs in symmetrical order. However, up till now, there is no rule which is discussed with you that how these binomial expansions are calculated. For this, I need to take you back to the Pascal's triangle, which is very famous. Pascal's triangle. In Pascal's triangle, you have to start from 1. And then in the second row, this is your row number 1. Or you can call it as row 0, row 0. Why not? I can write it as R0. R0 means row 0. Now row number 1, I'm going to write here 1 on the left and 1 on the right, and keep the upper one in the middle. Let's move to the row number 2. Apply the same procedure. Write 1 on the left, 1 on the right, and now what I'm going to write in the middle, the sum of these two numbers. So 1 plus 1 is how much? 2. Is it clear? Now let's go with the row number 3. As per previous rule, I copied 1 in the beginning and 1 at the end. Now I need to write a number right in the middle of the top row, 1 plus 2, which is 3. Got it? Now I'm going to complete the row number 4 by writing 1 on the left and 1 on the right, a little bit further from the previous row, to the left and to the right. So 1 plus 3 is 4, 3 plus 3 is 6, and 3 plus 1 is 2 and 1. One more row I will complete. Right, 1 here, 1 plus 4, 5, 4 plus 6 is 10, 6 plus 2, sorry, I wrote here 4, that was 2. That was 4. Okay, 6 plus 4, 10, and 4 plus 1 is 5, and here is 1. Now you can compare your binomial coefficients for row number 4. 1, 4, 6, 4, 1. Did you get the same thing? 1, 4, 6, 4, 1. Do you think it's a coincidence? No. Pascal triangles is a helpful tool to provide you the binomial coefficients. So it helps to provide the binomial coefficients. Now you can guess the expansion of a plus b whole power 5. What is the guess? You will say, Mr. Omar, since the power is 5, I'm 100% sure that in the expansion I will get how many terms? 6 terms. We are going to get 6 terms in the expansion of a plus b whole power 5. So 6 terms will come to us. Second guess. We should start first number, yani the first number here is a. We should start with the maximum power. So a power 5, and b should start from the minimum power, which is 0. So 5 plus 0 is 5. And then now power of a will be decreased by 1, and the power of b will be increased by 1. So sum of the power must be 5. Then a3, b2, then a2, b3, then ab4, then b5, and a0. You may check now the sum of the powers is equals to 5. Any objection? Now I need to copy the binomial coefficients. What is this? This is 1. I'm going to copy 1. Second one is 5. I'm going to write here 5. Then 10. I'm going to write here 10. Then 10 here. Then 5. And then 1. Wow. Thank you, Pascal triangle. You help us to write the binomial coefficients. But there is a problem. There is a problem in writing the binomial coefficients. The binomial coefficients, they are symmetrical. I totally agree with that. But if we will have a plus b raised to the power, we will have a plus b raised to the power 15. Do I need to waste my time in completing the rows of the Pascal triangle? No. So here, Pascal triangle, here, Pascal's triangle is not helpful. It's not helpful. What to do in this situation? We need to know the binomial expansion formula. Not in terms of Pascal triangles. We need to know a formula. Got it. Have you ever seen in your calculator this notation, NCR? NCR is a formula of combinations. check that where the combinations are written. Just see on top of division sign, there is NCR written. So to use this feature, we need to use, or we need to press shift. Suppose I want to find 5, shift division sign 5C2. So it gives us 10. I can write 5C5, it gives me 1. I can write 5C5, C6. The calculator is not giving an answer. It means that the bottom one cannot be bigger than the top number n. So let me explain you the concept of NCR. N is the total power, which is given before expansion. OK, and A plus, if I say A plus B raised to the power 15, so this is my N. What is R? Now this R is having all the values from 0 till 15. So if my N is 15, so my R starts from 0, then 1, then 2, then 3, 4, 5, 6, 7, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So it will help me to find all the coefficients of binomial expansion. So let me try to explain first A plus B whole power 5, but not with Pascal triangle. We all know with the expansion, I'm going to get 3 terms. Sorry, 6 terms. We all know the first power starts from the maximum. So A power 5, A power 4, A power 3, A power 2, A power 1, A power 0. Then the second term will start from the 0 power 0, 1, 2, 3, 4, and 5. Now come to the binomial expansion formula to write my binomial coefficient, but don't use Pascal triangle. I'm going to write here 5C0, 5C1, 5C2, 5C3, 5C4, and 5C5. And if you calculate 5C0 from the calculator, 5 shift division sign 0, it gives me 1. What is 5C1? It gives me 5. And then this will be 10. This will be 10. This will be 5. And this will be 1. Wow. So it gives me the same answer which the Pascal triangle was giving it to me. Now, with the help of this formula, I can write any binomial expansion. Suppose I want to do A plus B raised to the power 8. So A tells me how many terms will come to me in the expansion. I'm going to get 9 terms. Going to get 9 terms. So how I'm going to get the numbers? The binomial coefficient first, 8C0, 8C1, 8C2, 8C3, 8C4, 8C5, 8C6, 8C7, and 8C8. And then A power 8, 7, 6, 5, 4, 3, 2, 1, 0. And the power of B will be 0, 1, 2, 3, 4, 5, 6, 7, and 8. Wow, I did the expansion within no minutes. So guys, binomial expansion is in front of you. And you can see how the power is coming. Can you subtract 8 minus 0? It will give you 8. 8 minus 1, it's 7. 8 minus 2, 6. 8 minus 3, 5. 8 minus 4, 4. 8 minus 5, 3. 8 minus 6, 2. 8 minus 7, 1. 8 minus 8, 0. Wow. So there is a connection of the first power with NCR. And the second thing is, which you can notice, if this is 0, this is 0. This is 1, this is 1. This is 2, this is 2. This is 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. Bravo. Can I write a general term in the expansion of a plus b raised to the power 20? Can I write any term out of those 21 terms which I will get? Can I write any term? Because I want to write the formula. Expansion formula. How can I write it? I will write here A and B. I need to write some power here. I need to write something here. I need to write something here. I need to write something here. So my friends, it is always 20. This is R. I don't know which term I'm looking for. So this is R. So that has to be 20 minus R, and this is R. Now this R can be 0, 1, 2, 3, 4, 5, 17, 18, 19, 20. So any value of R from 0 to 20 can be substituted here. But the formula will look like this. If you want to find any particular term, so this formula will be very, very helpful for you. Done? Now be careful. Sometimes B has a minus sign, so you have to write here the minus sign with the B. In such a case, you will have sometimes alternatively the minus sign comes, but that will be seen later on. So to find a particular term, we have to use this strategy. I think it's better now to start solving the past paper questions. And then I will explain you furthermore about the binomial expansions, basic things, and those things which are related to the context of the question. So find the coefficient of 1 over x in the expansion of this. And he also gave you the coefficient of 1 over x. So may I take your attention towards 2x plus a over x squared whole power 5 . If we expand this, because here this is equals to a, and this one is your b, and this is your n. When I actually expand it, I'm gonna get how many boxes? I'm gonna get 6 boxes. And the binomial coefficient will be 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. And my A is 2x. So under the brackets, I will write 2x starting from the maximum power 5. This is 2x. Now I will write 4. Then I write 2x power 3. Then I write 2x power 2. Then I write 2x power 1. Then I write 2x power 0. What is the b? The b is a over x squared power 0. A over x squared power 1. A over x squared power 2. A over x squared power 3. A over x squared power 4. A over x squared power 5. Right? Now the thing which is important here to understand, I know I can easily simplify 5C0. That will be equals to 1. And then I have here 2 to the power of 5, x to the power of 5, anything power 0, it is always equals to 1. 5C1, which is 5. Then 2 to the power of 4. And then x to the power of 4. Then a over x squared. This will give me 10. This is 2 to the power of 3, x to the power of 3, then a squared over x power 4. Then 10, then 2 to the power of 2, x to the power of 2, then a power 3 over 2 times 3 is x power 6. Then 5C4, which is 5, and then 2x, then a power 4 over x power 8, because 2 times 4 is 8. This is 1. This is 1, because anything power 0 is always equal to 1. A power 5 over x raised by 2 times 5 is 10. Now you need to simplify. When you simplify this expression, guys, when you simplify this expression, it gives you 32 x power 5. I will get 32 x power 5. When I cancel them, I get 16 times 5, which is 80 a x squared after simplification. So this is 2 times 3 is 2 power 3 is 8. 8 times 10 is 80. So I'm going to get 80 a squared and x cubed cancel this one. I get x. So this is the expansion. 4 times 10 is 40. Cancel them. So it gives me a cube over x power 4. 2 times 5 is 10. Cancel x with x 8. A power 4 over x power 7. And then finally a power 5 over x raised by 10. Now, you will definitely ask me a question, Mr. This question has 3 marks, and do we need to spend this much time on this question to get this 3 marks? No, you need not to do this. How I can easily figure out the maximum power here for x after simplification will be x power 5. And then here I was having after cancellation x squared. Here the power was x power minus 1. Here the power was x raised to the power minus 4. And here you saw the x power minus 7. And then you had the x power minus 10. How can I get them? Is there any special rule which can help us to find these powers? The answer is yes. Let's come to this. I wrote for you 2x plus a over x squared raised to the power 5. What I will first advise you, send this x squared in the numerator. So you will get what? You will get 2x plus a x raised to the power minus 2 raised to the power 5. Now, what is the power of x you have here? The power of x is 1. So call it as u. Your u is 1. This is u. And your v is what? In the second term, the power of x is minus 2. And what is your n? Your n is 5. With the help of these three numbers, you will able to identify what will be the power of the first term. So you need to find nu. Nv will be the power of the last term, and v minus u will give you the step of the powers. So let's look at that. Nu, n is 5 and u is 1. So I'm getting 5. N is 5 and v was minus 2. So it's minus 10. V minus u minus 2 minus u. So minus 2 minus 1 will be minus 3. Do you agree with me? The first power for me is in the expansion should be 5. And the last power for the x should be minus 10. And each time the power should be decreased by 3. Can I write the next power after decreasing the power by 3? So it should be 2, then minus 1, then minus 4, then minus 7, and then minus 10. Did I get the same powers, guys? Same powers came to me. The examiner gave you a guess. He said he is looking for 1 over x. Yani x raised to the power minus 1. And x raised to the power minus 1 is your third term. If it is your third term, then it means what is the formula, the general formula you are going to build? So you started from 0, 5c0, this was 5c0, this is 5c1, so that has to be 5c2. So if it is a third term, you have to write here 2, 5c2. Just copy the coefficient of x, which is 2 here. And the second one is a. What the rule I have told you, 5 minus 2, it is 3, and you have to write here a squared. That is the coefficient of x power minus 1, which I already got, which I already get it here. So let me erase everything now and try to explain you how you will solve in the exam to get the 3 marks. So I am looking for 1 over x, which is x raised to power minus 1. Can I rewrite this expansion? This expression? 2x plus ax raised to power minus 2 raised to power 5. Now write, what is your u? My u is equals to 1. What is my v? V is equals to minus 2. And what is my n? That is equals to 5. So this is my n, this is my v, and this is my u. After writing uvn, I am gonna quickly write nu, which will give me 1 times 5, or 5 times 1, 5. This is my first term power of x. Next thing is nv. Minus 2 times 5 is minus 10. This is the power of my last term in the expansion for x. And then v minus u is the term each term will be decreased by this value. So v minus 2 minus 2 minus 1 minus 3. So how the powers will come to me? The first power will be x power 5. Then each time the power is decreased by 3. So may I guess the next power of x will be 2, then minus 1. I need to stop it here. Although I can continue, minus 4, minus 7, and last power is minus 10. But I am looking for this. Since I'm looking for this, this is my third term. So starting from 0, NC 5C0, 5C1, 5C2. So this is 5C2. I'm going to write here 5 minus 2. And here I'm going to write here 2. What I have to write it here? No need to write x because we already know after simplification we are going to get the x power minus 1. So just copy here 2. And here is just a. Copy it. And put it equals to, he said it is equals to 720, the coefficient. Now we can simplify what is 5C2. 5C2, it gives us 10. This is 2 raised to power 3. This is a squared, and this is 720. Now this is 80. A squared is equal to 720. So a squared is equals to 9. So it tells you a is equals to plus minus 3. Did he mention a is a positive value? No, he said possible values. So possible values means a should be plus minus 3. Guys, do you agree with me how to solve this question within 3 minutes? So this is the way you have to use. You cannot do the full expansion. It will take a lot of time for you. Hence, find the coefficient of 1 over x power 7. So this is x raised to power minus 7. Where is x raised to power minus 7? Guys, this is the second last term. Can easily do that. So 5C0, 5C2, 5C1, 5C2, 5C3, 5C4. So 5C4, 5 minus 4, and here is 4. I'm going to write here 2 and a. Clear? The value of a has been already found by us, which is plus minus 3. I'm going to write here 5c4, which is 5. This is 2. And the a is plus minus 3. Now I can simplify. There is no significance of plus minus sign here because the power is 4. Always we get a positive answer. So 10 times 3 raised to the power 4 gives us 810. That's all with this question. The next question, he says, first 3 terms in the expansion in the ascending powers of x. If x is at the second place, always you get ascending powers of x. Yani the power of x will be increased. So let's start with it. First thing is 5c0. 5c1. 5c2. 5, 4, 3, 0, 1, 2, 1, 1, 1, x, x, x. So what I'm gonna get? 1 times 1 times 1 times 1 times 1, 5 times 1 times x, 10 times 1 times x squared. So the expansion is 1 plus 5x plus 10x squared. This is the expansion which I will get. As the examiner wants the first 3 terms, I did it in front of you. Now find the first 3 terms in the expansion of this. Can I do the same thing, guys? 6c0, 6, 0, 6c1, 5 and 1, 6c2, 4 and 2. I'm writing it here now. 1, 1, 1, and minus 2x, because here the b is minus 2x. Don't forget to copy the negative sign also with the coefficient. So I'm going to write here 6c0, it is 1. 1 power 6 is 1. Anything power 0, it is also equal to 1. 6c1 is 6. 1 power 5 is 1. And then minus 2x. 6c2, let me calculate. 6c2, it gives me 15. And then 1. Minus sign will be eliminated because of the square. Just 2 square is 4. X squared. Final answer is 1 minus 6 times 2 is 12x, and 15 times 4 is 60 squared. So I found the expansion of this. Now, hence means we need to multiply them together. We got the first 3 terms in the expansion of 1 plus x5. Let me copy them. 1 plus 5x plus 10x squared. The other 3 terms, we don't need to write it here because he didn't ask us. Otherwise, the 3 terms are there within this bracket. And 1 minus 2x raised per 6, we got 1 minus 12x plus 60x squared. And the other 4 terms we need not to write. Clear? Now, is he interested in the full expansion of yani the multiplication of every term in the first bracket with the terms in the second bracket? No, you just need to see how you can get x squared term. Now, try. Is it possible 1 times 1 will give you x squared? No. Do you think 1 multiplied with minus 12x will give you x squared? No. 1 multiplied with 60x squared can give you x squared. So you just need to keep only the multiplication of 1 with 60x squared. I'm going to write here 60x squared when I multiply 1 with 60. This is done. Now check 5x multiply with minus 12x can give you x squared term. So multiply them together. 5x should be multiplied with negative 12x to give you x squared term. Now 10x squared multiply with 1. 10x squared should be multiplied with 1. Don't care about those terms which you didn't write, and there is no chance that if you multiply them, you are going to get an x squared term. That's why the examiner has made you to find the first 3 terms of the first bracket and the second bracket, because when you multiply them, the chances of getting x squared is only there. So I'm going to get 60x squared minus 60x squared plus 10x squared. This is cancelled. So my answer is 10x squared. And he is interested only in the coefficients. So if he is interested only in the coefficients, so you need to write only 10 in the exam. So answer is, because 10 is the coefficient of x squared. Question number 3. He said, find the term independent of x. Independent of x tells you a term which has no x. A term which has no x means it must have x power 0. Right? Apply the technique which I have taught you. What is your u? What is your v? What is your n? Let me copy here. 3x plus 2. X squared becomes x raised from minus 2 here. Now come on, boys. Right here, your n is 6. Your v is minus 2. And your u is 1. U is 1, v is minus 2, and n is minus 6. U is 1, v is minus 2, and n is 6. Can you find nu, which is the first power of x? That term which contains that first term which contains the power of x, 6 nv minus 12, and the step v minus u, which is minus 2 minus 1 minus 3. So how the powers comes to you? Starting from 6, decreased by 3. Wow, so that has to be the third term. Did you see, guys? Nu and v, and the step is always the terms are decreased by 3. And I am looking for a term containing no x, independent of x, and which is here, the third term. I'm going to write 6 C2. Just write 3 because x has been already sorted out. After simplification, you will get x power 0. So just write 3, 6 minus 2, which is 4. And the second number is 2. That's your final answer. 6, 6, C2, 3 power 4, 2 power 2, 4, 8, 6, 0. And that's all with it. Now, he wants you to find the independent term when this term and this term both, when both brackets are multiplying with each other. As you have seen in the previous case, when we expanded this, how the powers of x came to you, you got x power 6, then x power 3, x power 0, x power -3, x power -6, -9, and -12. And how the 1 minus x power 3 will give you, when you expand it, it is obvious. You will have x power 0 and x power 1, 2, and 3. I can prove it to you guys. 1 minus x power 3 whole power. Is it 1 minus x whole power 3 or 1 minus x cubed? Quite interesting. I check it again. It's 1 minus x cubed. Oh, it's inside. It's not outside. Just right here, 1 minus x cubed. Now, guys, check that how you can get with the multiplication of two brackets. We have a chance of getting x power 0. So 1 multiply with x power 0. And x cubed multiply with this term. Minus x cubed multiply x minus 3. Now, boys, you need to understand how these two terms will be written. This term is already found by us. That was 4860. This was 4860. So I'm going to write here 4860. 1 multiplied with 4860. I want this one. So this is the fourth term. I will write here 6C3, 0, 1, 2, 3. 3 raised to the power 3 and 2 raised to the power 3. Can I simplify and calculate this value? 6C 3 times 3 raised to the power 3 times 2 raised to the power 3. It gives me 4320. So this is 4320. I'm gonna write here 4320. And here we have -1 multiplied with this. So 4860 minus 4320. I'm not interested in writing x power 0. Just these two terms will be simplified. 4860 minus 4320 will give us 540. So when you simplify them, you will be getting 540 x power 0. Let's go to the next question. The coefficient of 1 over x. The coefficient of 1 over x means I'm looking for x raised to -1. In the expansion of this is 74. There. Let's have a look on ax plus x raised to -1 raised to 5. Your u is 1, your v is -1, and your n is 5. Your NU is 5. Your NV is -5. And your V minus U is -2. How the powers looks like? X power 5, X power 3, X power 1, -1, -3, and -5. So I'm interested in this term. Also, he gave me 1 minus 2 x power -1 power 5. My u is equals to 0 because x power is 0. V is -1 and n is, this is 8. Can I find my nu, which is 0, nv, which is -8, v minus u, -8 minus 0, -8. Each time the power is decreased by, v was -1, sorry. So each time the power is decreased by -1. Starting from x power 0, x power -1, -2, -3, -4, -5, -6, -7, -8. Here, x power -1 is this one. Can I calculate this? 0, 1, 2, 3. So 5C3, 2, and this is 3. I'm gonna write here K, and this is 1 because this is K, and this is 1. And in this case, I'm gonna write 8C1 because 0, 1, 8C1. This is 1 raised to power 7, and -2 raised to power 1. He said the coefficient is 74. So sum of these two numbers, 5C3 K squared plus 8C1 minus 2, it is equals to 74. Now I need to simplify this. 5C3, which gives me 10K squared, and 8C1 is 8, so -16 is equals to 74. 10K squared is equals to 74 plus 16. 10K squared is equals to 90, and K squared is equals to 9. K will be plus -3. Did he ask us to find the values? Positive value. So ignore the negative value. Ignore K is equals to -3. So your solution will be K is equals to 3. That's the final answer. Find the coefficient of x squared. So x minus 2x raised to power -1 whole power 6. U is equals to 1. V is equals to -1. And n is equals to 6. Nu is equals to 6. Nv is equals to -6. V minus U is -2. How the powers of x will come to us? 6, 4, 2, 0, 2, -2, -4, and -6. I'm looking for x squared, which is 6C012. What is the coefficient here? 1. And what is the coefficient here? -2. So 4 and 2. Six C2 times 1 raised to power 4 times bracket open minus 2 bracket close raised to power 2. We got 60. That's the answer. Now we need to find the coefficient of x squared in the expansion of these two brackets. 2 plus x squared will not be expanded because its power is 1. I'll just copy it as it is. However, x minus 2 over x whole power 6, we already know how their powers looks like. X power 6, x power 4, x power 2, x power 0, minus 2, minus 4, and minus 6. I'm looking for x squared term. So 2 should be multiplied with this term. And x squared should multiply with this to get you x squared. So 2 should be multiplied with this one, which we have already found it in the previous case. That gives us 60x squared. This was 60x squared. So I'm going to multiply with 60. If you want to write x squared, that's up to you. And 3x squared is going to multiply with this term. Can I try to find it? This will be 6C0, 1, 2, 3. 1 and minus 2. Try to calculate it. 6C3 times minus 2 raised to the power 3. It gives us minus 160. Minus 160. This will give you 120x squared. Minus 360 x squared. We are looking for a coefficient of x squared, which is minus 360. That's the final solution. Expand 1 plus a whole power 5 in ascending power of a up to and including the term in a power 3. So let's start expansion. 1, 5C0, 1, starting with the maximum 5 minus 0. So he wanted us to expand it till a power 3. 1 times 1, 1 because this is 1, and this is 1, and this is 1. Then 5, then 1, then a, then 10, then 1, then a squared, then 10, then 1, then a power 3. So after simplification, we will get 1 plus 5a plus 10a squared plus 10a power 3. That's the final answer. Now, hence, so we need to use the previous result. That was just 1 plus a. It looks like he has written in the place of a x plus x squared. It is for a. Can you write this value here, here, and here, and then try to expand it? So substitute a in the place of a x plus x squared. Now we need to expand them. This is very easy. I can do the binomial expansion here. So 1, 1, 3, 3, 1, or why not? We can get this expansion on the side. So let me try to get x plus x squared whole squared first. So this is found. Now I'm going to find x plus May I write the expansions here? I'm sure you guys are not convinced with this computation because the marks are 3 and I spend a lot of time on it. Can I tell you what is the background of this expansion which is asked by the examiner? He doesn't want to waste your time. You know what you need to do when I ask you find x plus x squared raised by 2. You can take x common. When you take x common, so the square will also come along with it, and you will have here inside the bracket 1 plus x raised by 2. And x plus x squared raised by 3 means when you take x outside, it will be x cubed and 1 plus x whole power 3. This expansion is very easy. 1 plus 2x plus squared. So you will be getting 1 plus 2x plus x squared. And this expansion will be 1 plus 3x plus 3x squared plus x power 3. And then you can multiply the brackets. But anyways, whichever method suits you, you can follow it and just solve this question. Now I'm gonna expand 1 plus 5x plus 5x squared plus 10x squared plus 20 x cubed plus 10 x power 4 plus 10x cubed plus 30x4 plus 30x5 plus 10x6. Hence expand it to x power 3, 1 plus 5x. Do we have any 5x? Okay, no. So plus 5x squared plus 10x squared is 15x squared, and x cubed is plus 30x cubed. I don't need these terms in the expansion. Another thing which I have noticed just now, that examiner is not interested in all the terms of this expansion. So here I can also save your time. Let's redo the question. How? Look at that. 1 plus 5x plus 5x squared plus 10. You need to expand it. So this is x squared plus 2x cubed plus x4, which is not needed. And here, just start with the first power, x power 3. The rest of the powers are not needed. I don't need this one. Then you just need to simplify them. So what is the final answer? This can save your time. How the student can reach to this target? Because they keep an eye on this x cubed. And this one, when you do the expansion of x plus x square whole power 3, you will get bigger and bigger powers of x. So there is no chance you are going to get x cube again. So the first power will be x cubed because my first number is x and it starts with x cubed. That's why I just copied x cubed. But here, my first power start with x squared. So I need to go to the second term, which is 2x cubed. So two terms in this expansions are needed. And I think it's not a big problem for the student to get the expansion of x plus x squared whole squared. I'm trying to save your time, guys. So because it has 3 marks. If you look into this, he said find the first 3 terms in the expansion. So 1, 5c0, 3 raised to the power 5. So 3 raised to the power 4 is 81. So 810 along with x. And then 27 times 4 times 10 gives you 1080 x squared. So this is the expansion for 3 minus 2x whole power 5. Then this expansion is already done, and now he needs also the expansion of this. When you multiply them together, you will be looking for the coefficient of x squared. First thing is, what is the expansion of 4 plus x whole squared, which is 4 squared plus 2 more and x then x squared, so it will give you 16 plus 8x plus x squared. Now let's write 16 plus 8x plus x squared, and he has made us to find the first three terms. 243 minus 810 x plus 1080 x power cube. No need to write the others. How the x square term will appear after the multiplication of two brackets. This was x squared, sorry. Now 16 multiplied with this will give you x squared term. This multiplied with this will give you x squared term, and this multiplied with this gives you x squared term. So 16 multiply with 1080 x squared, 8x multiplied with minus 810x, and x squared multiplied with 243. 16 multiplied with 1080, 17280 x squared, 8 times 810, it gives you minus 6480x squared plus 243 x squared. Now let me copy all the values. 17280 minus 6480 plus 243. It gives you 11043 squared, but I'm looking for the coefficient of x squared, so 11043. So that's all with it. The coefficient of x in the expansion of this is p. So 4x plus 10x raised to power minus 1 raised to power 3. Your u is 1, your v is minus 1, and n is 3. Nu is 3, nv is minus 3, and v minus u is minus 2. How the power comes to you? X power 3, 1, minus 1, and minus 3. We are looking for the coefficient of x. So 3c1, 4, 10. So this is 2, and this is 1. And he said it is equals to p. I'm trying to calculate p. 3c1 times 4 raised by 2 times 10. It gives me 480. I'm also trying to find the coefficient of 1 over x for the 2x plus kx raised by minus 2 raised by 5. What is u? 1. What is v? Minus 2. What is n? That is 5. And u 5. And v minus 10. V minus u minus 3. How the powers of x comes to us? I'm looking for minus 1. which is this. 5c2 2 k raised to the power 2. We said it is equals to q. 5c2 is 10, and this is 8, and this k squared is equal to q. It gives you q is equals to 80 k squared. Now he says, given that p is equal to 6q, given p is equals to 6q, p was 480, 6q is 80 k squared. Do we need to find positive values? Possible values. So k will be equals to plus minus 1. So this is my final answer. Write down the first 4 terms in the expansion. 6c0, 6c1, 6c2, 6c3, 6, 0, 5, 1, 4, 2, 3, 3. It is a minus x, minus x, minus x, minus x. I'm getting 1, a power 6. This is 1. I'm getting 6, a power 5, minus x, 6c2, 15, a power 4, x squared, 6c3, 20, a power 3, minus x power 3. So a power 6 minus 6 a power 5 x plus 15 a power 4 x squared minus 20 a power 3 x power 3. This is the expansion. Given that the coefficient of x squared in the expansion of this, we have already done this expansion. Let me copy them. 1 plus 2 over a x power negative 1. Let me copy here a raised to power 6 minus 6a5x plus 15 a power 4x squared minus 20 a power cube x cubed. I'm searching for the coefficient of x squared, so 1 should multiply with this, and this should multiply with this to give you x squared. So 1 multiply with 15 a power 4 x squared and 2 over a. I can write x down, multiply with minus 20 a power 3 x cubed. It gives you 15 a 4 x squared minus 40 a cancel with a cubed, give you a squared x squared, and he said that it is equals to minus 20, the coefficient. So I need to erase x squared from it. Now it turns into a disguised quadratic equation. use calculator. Go to the menu, equation, polynomial, P2, enter 15, enter -40, 20, 2 and 2 over 3. So a squared is 2 and a squared is 2 over 3. Possible values. So a is equals to plus minus square root of 2. A is equal to plus minus 2 over 3. Did he mention positive values? Find the exact formula. You need to give the answer in a third form. So a is a positive constant. So these are our possible answers. Now we reach to the next question. We have to get the coefficient of x power 4. So 2x squared plus a squared x power minus 1 raised power 5. Our u is 2. Our v is minus 1. And our n is 5. And u is 10. And v is minus 5. And v minus u is minus 3. Our powers 10, 7, 4, 1, minus 2, minus 5. We are looking for x power 4. So 5c2, 2 a squared raised power 2. He said it is equals to a. 5c2 is 10, right? A power 4. So a is equals to 80 a power 4. Second one is 2kx minus 1 raised by 4. I'm again looking for coefficient of x squared. What is my u? 1. If no power of x is here, so v is equal to 0, n is 4, and u is 4, and v is 0. V minus u is minus 1. Powers will be 4, then 3, then 2, then 1, then 0. He's looking for x squared. So if he is looking for x squared, so I'm going to write here 4c 2k, and -1. Don't forget this -1. Just to, he said it is equals to what? B. Simplified, 4c2 is how much? 6. 4 a squared 1 is equals to b. So b is equal to 24 a squared. We found a and b in terms of k. That was the question. The next part, he says, if a plus b is equal to 216, let's put a is 80k4. What is the b? We found it. 24 a squared is equal to 216, which is a disguised quadratic equation. Menu. 80, 24 minus 216. 3 over 2, and k squared is equals to 3 over 2 a squared is equals to minus 9 over 5. So square cannot be a negative number. Ignore. A is equals to plus minus square root of 3 over 2. So possible values of k are found. Next thing, the coefficient of x power 4 is equals to the coefficient of x squared. Three plus x raised by 5. Your u is equals to 0. V is equal to 1. Your n is equals to 5. And u 0. And v is 5. P minus u is 1. Powers 0, 1, 2, 3, 4, 5. You're looking for the coefficient of x power 4, which is 5c 4, 3, and 1. Raised to power. Raised to power 4, as he said. I need to simplify it. 5c4 is 5. So the coefficient of x4 is 15. Also, he gave you another number, which is 2x plus ax raised by minus 1 raised by 6. Here we are looking for coefficient of x squared. What is our u? 1. V is -1, and n is 6, and u is 6, and v is -6, and v minus u is -2. Now, powers of x, which we will get 6, 4, 2, 0, -2, -4, -6. We are looking for x squared, and this term is 62, 2, 4, a 2, which gives us 15 times 16 a squared 240 a squared. He said they are equal to each other. The coefficient of x squares are equal. Put them equal to each other. So 240 a squared is equals to 15. 15 divided by 240 gives you a squared is equal to 1 over 16. A is equals to plus minus 1 over 4. So values, he wants positive value. Ignore the negative value. That's your possible answer, right? Let's finish this question. We are looking for coefficient of x power 3. The expansion of this. P plus 1 over p x raised by 4. X is 0. Sorry, u is 0. V is 1. N is 4. And u is 0. And v is 4. V minus u is 1. Powers of x. 0, 1, 2, 3, 4. We are looking for x cubed, which is 0, 1, 2, 3, 4c3 p 1 over p. He said it is equals to 144. 4c3 is 3. This is p. This is 1 over p raised by 3. It's equal to 144. 3 over p squared is equal to 144. Or 48. Possible values. Yes, we found the values. Let me check it again. Yes, we found these answers. So inshallah, in the second video, I will explain the rest of the questions.